Hey everyone, my name is Ira DePris. I work for Manitoba Transportation Infrastructure for, I guess, the province of Manitoba, which is the DOT, I guess, up there, up north. There's two questions that we were supposed to answer, or I guess we were supposed to select one. Myself being from a materials group, specifications, and on the construction side, I thought it best that I approach it from a project perspective instead of pavement management. So basically I'll be talking about brief history of chip seals in Manitoba, some of the issues and challenges. Some of the issues and challenges that we've had, sort of a short document review that we did before doing specification updates, and then of course questions. So brief history. In Manitoba, prior to 2017, we had two in-house crews doing chip seals. These were graded aggregate seals using high float emulsions. Generally had good results, but slow cure, which meant slow cures, which was fine as long as you weren't going on high volume roads. So 2017, we trialed using doing a single chip seal using a CRS 2P. We didn't do that in-house. We contracted that out. It seemed to be something that we wanted to continue doing. So the following year, we contracted more of the single chip, the graded chip, and we also downsized to one in-house crew. And of course, that went to basically no in-house crews and everything being contracted out. So that was in 2019. So everything was being done either as a graded chip seal using HF 150 or a single chip using a CRS 2P. And so in 2021, with the growing pains of going from in-house to outsourcing everything, we started identifying several issues we needed to address. Some of that was due to spray patterns, application rates, the quality control, some of it aggregate retention. So we started doing a review of our chip seal specification basically last summer. And so with that, I wanted to share some of these issues and challenges with you guys. The first one really being gradation. So for aggregate acceptance, generally after production was done, we'd go in there with our loaders, or not we, but we'd be collecting samples from by loader sampling method. And then once accepted, that material gets moved on over to the staging area, stockpiles near the project site. So often we'd encounter issues as we're testing, even during construction, just to verify what's occurring. We'd have stockpile consistency issues, basically non-compliant issues, and it's kind of that too late stage where they're applying it to the road, and just different results from stockpile versus staging area. So, I mean, I have here, apples to oranges, so it was really odd and hard to put your finger on it what the issues were when you're looking at your results from stockpile production versus staging area, and it was very different. Other issues were design rates. So with the transition from in-house to using contractors for chip seals, I guess some of the growing pains were, contractors were really worried about the warranty. So they insisted on using, or they still do really insist on using very high application rates for emulsions and aggregates. So I have some conversions here for you guys, but so basically for using 0.44 gallons per square yard for emulsions. And so when you're using that much emulsion, they also have to use a lot of aggregates. So somehow these contractors are still low bid, and I mean that could just mean that we don't have a very competitive environment. We do have a lot of contractors coming from out of province to do some of our seals, and we do have a few contractors, local contractors doing seals, but it's definitely not a priority for them. A priority for them is more on the hot mix side of things. So those are some of the battles, and of course, like when you do have very high application rates, There's been a few talks, I guess, about some of the constituents and their concerns. Well, it does look like you're turning your road into a gravel road, and so that's not very fun to answer some of those questions. And then just general application rate errors being identified down the road. So not having a good, say, quality control plan and not really recognizing that your application rates are way off. Maybe you're 6 kilometers down the road. So those are some of the issues that we were encountering. Traffic management. Common practice was to pilot traffic on fresh seals. So stones rolling over into wheel path, looking like tracking, increasing the possibility of flushing and bleeding, vehicle damage claims, so very bad publicity. I don't think anybody wanted to drive through any of our chip seals. I'm myself, if I knew there was a chip seal in the area, I was not driving through that zone knowing that they would pilot us on that seal. So generally that was an issue. So we use a lot of high floats in Manitoba. High floats generally take a long time to cure, depending on environmental conditions. So, it could take 2, 3, 4 hours, depending on the weather, for it to cure. And then another issue, aggregate loss. Basically your worst nightmare. This is a picture of an area that almost has no aggregate left. That's all just emulsion. And so many reasons, really hard to put a finger on it sometimes when there's a lot of gaps to fill. Dust content, time of year, design rates, spray patterns, weather, aggregate type. We use a lot of limestone in Manitoba, especially around the city. So yeah, those were generally the issues that we were seeing. So we needed to do a review, essentially, or we wanted to do a review really of seeing what other people are doing to address some of these issues. There was the construction guide specification that was released as a draft. So we definitely looked at that. There was the NCHRP document. And then, of course, the Minnesota Chip Seal Handbook, the ISA guidelines, and then some of our counterparts that are here, Saskatchewan, Alberta, Ontario, and the US DOT specifications. And then from that, the chip seal spec was born. So, and I say that because we were really operating out of a tender. We didn't really have a specification actually written out, posted online. Everything was always done through tender format. So this is actually the first chip seal spec in Manitoba, finalized in 2022. And some of the major updates were implementing a quality management plan, using test strip for application rates, to determine or finalize your application rates, addressing some of the issues with our transverse joints, so overlaps, some of the rolling operations, protection of motoring public, and then aggregate acceptance was another one. So with the transition from in-house to contractor, there is a huge transfer of QC responsibility to the contractor. It was a component we felt like was missing, so essentially at the start of construction, prior to pre-construction meeting, we asked contractors to submit basically a quality management plan, addressing everything from personnel, the equipment to perform the work, laboratory qualifications, so the lab doing the testing for the aggregates, test frequencies during aggregate production, making sure they even do it, calibration process for the distributor and spreader, monitoring and inspection documents to make sure they can capture some of the issues as they encounter them and address them, and then identifying any other construction requirements we might throw into the specials. So the QMP essentially, what it did for us, this was the first year we, because it was developed and finalized in 2022, we had three contracts. It was the first year to use it, and it really gave us an opportunity as an agency to provide guidance and identify gaps, say in their processes before they even get to the project. That's really what it did for us. So this is just a snapshot of the calibration process. So Procedures were largely based on the AASHTO guidelines, and I should add the NCHRP document too. They both had their qualities. So for the asphalt distributor, we used to really only do distance and volume calibrations. We added nozzle orientation, spray bar height, nozzle flow in there, and then for the aggregate spreader, I am not sure that we really did much other than verifying maybe the longitudinal spread during construction, but what we asked is that they calibrate their spreader prior to the start, and so that's for the transverse spread and the longitudinal spread. So one of the pictures is for the transverse spread, and the other one was for the nozzle flow, which is you see the concrete cylinders lined with plastic on a pile of sand there. So none of this makes a contractor happy to go through all this, but it definitely made us happy to see that everything was working appropriately prior to start. So for the design submission and the test strip portion of the work, we're accepting the McLeod method and the new I guess the AASHTO spec. I'm actually not sure if it's still provisional or if it's actually just in AASHTO anymore, but all of our contractors still are electing to use the McLeod method. It's the method that everyone, I guess, prefers at this point, but I expect to see maybe a transition to AASHTO. I'm not sure, but we're talking internally anyways. It might be a better method for single chips. Aggregate submission happens at design as well, and we ask them to do that so we can verify fractured faces, the LA abrasion, the ironstone content lightweight, so make sure they meet all of our requirements. Generally, we accept at the design stage, and that's also when they provide a summary of their quality control results. And then shortly after that, once we can kind of move on from the design submission stage, we get into the test strip where we confirm or modify, say, application rates to the condition of the road. So we never really had tolerances in the past for changes. We added a tolerance of plus minus 10% for the aggregates and 5% for the emulsions. We were hoping that would help, say, with over application of emulsion and aggregates. It was a bit of a battle. We still had a contractor insist on using much higher application rates. So it didn't exactly help address that. At the end of the day, we get a good product. Even when they do that, we haven't identified any major issues with it other than the fact that it's a lot of material and ends up, causing quite a few complaints from the public when they go and look at this, and it looks like a gravel road. And I guess the other part of it too for us is it's hard to imagine doing something like maybe a racked in or a double chip when the application rates are that high. For transverse joints, we encourage the use of tar paper to eliminate transverse joint overlap. Contractors could eliminate the need for tar paper if they could demonstrate the acceptable transverse joint. At the end of the day, no one used tar paper, but what it did do is enforce what we wanted. We wanted a clean joint. We do not have a huge overlap. This is actually a picture from Google Earth, last minute looking for something to throw in a slide. And somehow we found something on Google Earth, just off memory. We found this spot here. This is just a bit of an overlap. It's an eyesore, but it's also a problem, I guess, once the plows go over these areas and we lose all of the stones, and it just looks like a nice black streak on the road, and so causes a lot of eyebrows to rise. And so this is something we wanted to address, and I think we did this year, just by basically bringing awareness that that's not what we want. We don't want 100 mil overlap. We want clean transverse joints. So protection of motoring public is what we called it. I think actually AASHTO calls it that too. This is not necessarily an AASHTO clause, but we kind of stole it from there in a way. So for piloting traffic for the graded seals, there's no piloting of traffic on the seals for 3 hours. And for a single chip, it's 1 hour. It seemed like talking to the project manager, I actually spoke to him before coming up here, and it sounds like it was actually very well received by the contractor, which was surprising. We thought we'd have a bit of a battle with the contractor on that one. But there were no issues there, and it actually reduced the amount of, say, complaints from the motoring public because they weren't forced to drive on a fresh chip seal. So it actually worked out really well. It's probably one of the biggest wins this year, was actually not allowing our contractors to pilot traffic on the seals, the fresh seals. And of course, not of course, but this applies to our construction traffic as well. So gravel trucks tended to drive on their fresh seals, and that of course causing issues with flying stones. So we enforced it for even the construction vehicles to stay off the seals until they cured out. And then for aggregate acceptance, we moved on to a lot system. So a lot system was basically a 10 to 15 lane kilometers. We grabbed 3 samples per lot, and this all came from the staging area stockpile. So as they're loading up their trucks, every once in a while we ask them to lay down the aggregate, and we'd grab samples from there. It worked out really well. We had some really good consistency, and we identified issues as work went on. It even actually forced their contractor to think about it a lot more during production, and even during construction. They started grabbing their own samples so they can understand the difference between, say, stockpiling aggregates versus, say, moving the aggregates, because when you do move, say, a limestone material, you do end up producing a lot of dust if you're not paying attention, and so that being an issue for single chips. And so there was also a pay adjustment that was based off of a lot mean deviation from the specification limits. And of course, with that, you have an appeal system and everything. So we've yet to debrief a contractor on the entire process, but it seemed to be a really successful year for chip seals, and that's just a picture of a completed project, and hopefully it stays that way.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.